If everyone can listen here. Yes, this is more or less the last theoretical lecture of this course. Next time we will look a little bit into the exam and what you have to prepare for there. But today's topic is developing web applications. We have already looked at a lot of technologies and specifications related to web technologies. I will mention a few more today as well, but we will also have focus on trying practical implementation of web applications. So I have a larger workshop this time than other lectures that I had. So I think that maybe we'll use the first session now, 45 minutes or so, on some theoretical things, and then we'll form groups and do a larger workshop than we have done.
Is that slide available?
Yeah, it is. Actually, it breaks the pattern of the numbering that I've used before, because it's lecture 08.
Where is 07?
Yeah. I shuffled the lectures this year. Yeah. So it was different last year. That's why it's 7 is gone. Yeah. So 7 is actually the lecture that Rune gave. Yeah. So you'll find it on GitHub.io. More or less the same address as before, instead of 05 or 04, 08. Yes. Topics. We'll look into experimental APIs. And these are APIs that are still not. They are either working drafts or they are specifications made by organizations that have interests in web technologies. We'll look at general web security, layered security, secure web application development, and polyfilling. Okay, experimental and future APIs. We have already mentioned the file APIs. That means the file API with, for example, the file reader interface and several different APIs beneath there. I think someone mentioned that this was deprecated, and I checked up on that. It's still a working draft, so it's a part of VGC's roadmap, so to say. So it's not deprecated. It's for reading files and data chunks within files. You can look at this example on html5.rocks.com if you want to. There are several device APIs coming. We don't know if they become specifications or recommendations, but they are being worked with in the specification organization, either V3C or WhatVG. First of all, network information API to retrieve network information, better or more fine-grained network information than you can by several different polyfill methods at the moment. Through the network information API, you have the vibration API that can actually detect whether or not, or trigger vibrations on mobile devices, for example. The battery status API, device orientation event. What device orientation does a handheld device have? Ambient light events, trigger events depending on a light sensor. in your device, and several others. There are a lot of APIs that are being worked on. We also have several different interaction APIs that improve user interactions, such as interaction in gaming, for example. So you actually have a gamepad API, so that JavaScript can communicate with a gamepad input interfaces. Pointer lock API. Have you tried gaming or using web-based games that you use in your browser? And then pointer events are not being triggered as when you go outside the browser window. This is typically quite annoying. So the pointer lock API gives a more fine-grained mouse pointer information, and it can also retrieve information whenever the pointer is outside the browser window as well. And there are others in this category as well. You have web notifications, native notifications like growl messages on your Apple computers, or Android notifications on phone, or iOS notifications. These can be triggered with the notifications API. WebRTC, I've already mentioned a little bit about that. Peer-to-peer media and file sharing. And how can we see whether or not we can use these? We can use caniuse.com. I've already showed you that a lot of times. For Internet Explorer, you can use status.modern.ie or HTML5test.com for testing HTML5 features. We can look at caniuse.com now. We'll see that. Oh, sorry. There's a searching feature there. You also get a list of all the APIs that are quite new, like the JavaScript APIs, ambient light, battery status, beacon API, clipboard API, file API, file reader API, full screen API, etc., etc. So if you want to look into this, is a great resource to looking into the features that are coming in web browsers. There are also lists for SVG, HTML5, and CSS as well. Yes, so that was some of the features that are coming, or the specifications that may come in the future. Let's move on to security in web applications. Okay, I know that most of you have already developed web applications before, or have experienced some web application development in this course, for example. But can you think of any security threats, for example, in web applications? None.
Well, you can, if you use cookies, for example, for authentication session, somebody can steal your cookies and use it as authentication.
Yeah.
So you can use, for example, HTTPS only cookies to send them, or you can store like user password as a plain text somewhere. I don't know.
Yeah, you could do
Stuff
that.
like this.
You should. That's your point, isn't it? Yeah. But cookies. That's a good example, because you can steal cookies, and then you have the actual session token that you use for authentication without putting in your password and user information at every request. Because many systems use cookie authentication and authorization. So that's a good example. How threats that you know?
Anything related to user input?
Yeah.
Injections?
Yeah, exactly. What kind of injections?
Database injection or even cross-site scripting?
Database injections or SQL injections, command line, no, command injections in your server-based programming language, like injecting PHP commands in PHP, for example, and other different injection methods or threats. Others, XSS. You mentioned XSS. Do you remember what that is?
Well, it's tampering with the HTML and like injecting JavaScript really. Like it's not delivering the HTML file that I originally intended to get, but it's a modified version with routines or methods that I don't want to use, malicious ones.
So you can trigger JavaScript with, for example, passing JavaScript in a get parameter, for example. If that is not correctly sanitized, it will render in your page, and then it will trigger you can trigger JavaScript with this kind of.
For example, if you have a web application and someone reverse engineers your web application and starts using your API without your permission.
That's also wrong. Okay, let's look into all of those I have in my. These are not all the threats that you have, but some of them, the most major ones. Web security in general, threats and security concepts. What threats do we have? DOS, denial of service. You heard about that? Yeah. Or distributed denial of service, DDoS. Attacks aiming at making a service unavailable for its user, accomplished either by forcing computer to reset or consuming computer resources. For example, network-based attacks overloading a service with network packets. So you're more or less trying to wrestle down the service by brute force, more or less. So either you have a lot of bots or something, or a lot of users trying to attack the same server, for example, the same service simultaneously, and hogging its resources, and therefore hogging resources for others using this service as well. Either you make this service really slow, or you completely break it down. Denial of service. Eavesdropping. Listening and sniffing on a network connection, e.g. sniffing TCP packets. So, what is meant by that? Sniffing TCP packets.
When somebody is listening, well, it depends on what kind of networking you use. But for example, if you use Wi-Fi, you potentially can set up your Wi-Fi adapter so that it will accept all packets independent of like MAC field or anything. If it's connected to you or not, so it will just gather all packets and you can look what devices send what data. Or if it's like malware in the computer, you can just listen to traffic on some interface, get all the packets that go through it.
Yeah, exactly. And that's what you do. You get if you somehow are able to set up a system that picks or interferes or sniffs on all the TCP packets. You can open these TCP packets, look at the content, and there you can reveal secrets, for example, that are sent, secret information that are sent back and forth between servers. So that's sniffing and eavesdropping.
Yeah, by the way, it was a very good example recently about web application and sniffing traffic. There is an application called 1Password or something like that, when you have 1Password for all the websites and everything. And they had extension in Chrome. And how service that was running on the machine was sending passwords to this Chrome extension, and they used a local interface to send password, but it was just sent as plain text, unprotected.
Yeah.
So anybody who had rights to listen to interface in this computer could just read this password and even credit card and stuff like this.
Yeah, exactly. And typically, like viruses and other type of threats on your computer can start sniffing your TCP connections and then start unpacking the TCP packets that are sent back and forth. Phishing is quite related to eavesdropping as well, masquerading as a trustworthy entity, directing users to fake websites, e.g. fake wireless networks or fake linking in emails. With my mobile phone, I can set up a wireless connection so that anybody can use that. Let's say that I set up a program that maybe routes every Facebook.com request that a user does to my Facebook.com with a login and password form. Then I can set up this open wireless network endpoint and maybe in a public place or something, and maybe a person besides me see that, okay, here's a free open network, that's great, open free wireless, and he or she hooks up to that wireless network. Then I can start routing this user to wherever I want, if I have the correct software or I set up the correct software myself. So I can show this user a fake Facebook.com web page on the domain Facebook.com with the same login form as Facebook.com gives you. And he or she maybe logs in with the username and password. Okay, then I have that. And then I redirect the user to the real Facebook.com page. And he or she wouldn't have even noticed that I fished the password and username from them. So that's phishing. Have you heard of similar attacks like that? No?
But when they log in on the fake Facebook.com, they will be sent to the real one already logged in, or they will have to log in again.
No, you can. Yeah, you can.
No, I said they have to log in again.
Because what?
No, that depends on how you set it up.
Okay.
Yeah. Because let's say that you route everything that goes to the first time someone goes to www.facebook.com. You route everything on that domain to login.facebook.com, and you set up a fake login on login.facebook.com. Okay. Then you set up a totally normal form, maybe a JavaScript behind or something like that, or sending the information to your server or something like that, your server on the phone. And somehow you get this user login and password. How you do that depends on how you implement it. And then you redirect the user with this post parameters, username, password, to www.facebook.com. Then you have set up this system so that the user can't see that they don't have to log in two times. So you can set it up like that. It is possible. Of course, you need a domain server as well on your phone, so that you route the users to your server instead of.
To what degree does HTTPS
solve this problem. For example, if we set this up now, and I try to access Facebook on my computer,
Yeah.
will my computer try to connect to HTTPS? And then it's probably going to fail because you don't have a Facebook certificate. And or will it try to connect through HTTP? Or will it somehow discover that, oh, you're trying to connect to Facebook and it doesn't have HTTPS, that's something wrong. And then it shows me that Chrome, something suspicious with this website page.
If you will request HTTP, Facebook.com, everything will go okay, like nobody prevent this. But if you, for example, use this HTTPS everywhere extension, then it will automatically redirect you. Or there is actually one thing that if Facebook sets the header, there is a header that says that this website is available through HTTPS. And then even browser, each time you access it via HTTP, it automatically redirects you on HTTPS. And at this point, your browser will, of course, say that that's not the same website because, of course, certificate is not valid. So HTTPS solves this problem, but if website supports HTTPS and works only on HTTPS.
Yeah, so typically on Facebook.com login is of course on HTTPS.
Yeah.
So because of that, you will have this second login thing. So you have to log in twice, actually. Yeah.
But yeah, if you just went to this website on HTTP and get this form, enter your login credentials, then yeah, you will not be authenticated on real Facebook. But after that, it doesn't matter actually because your password.
Yeah, for the attacker it doesn't matter,
Yeah.
because he or she has already gotten a username and password.
So each time you use public Wi-Fi, do not enter your credentials on HTTP.
If you don't know the Wi-Fi, it should be quite. Yeah.
Yeah, but is there any like Chrome or any browser support for this that detects that you're an HTTP on this website that it normally has HTTPS?
That's how you can.
You need plugins for that because the transaction rules for that in the browser.
Okay, so there's no like browser doesn't look at statistics and see, oh, you always use HTTPS on this website and you're using HTTP now. That's wrong.
No, I haven't heard about that because these are kind of then you have to have some kind of inference functionality in every client for every computer, but they don't do that. But because they have to be quite ignorant and follow the standards related to this instead of inferring the threats by their own. So I don't think there are anything like that. But what you have is trusted authorities. So you check up the HTTP certificates against trusted authorities. So they do that. That's the standard way to do that. And then that is why you get this green bar if the certificate is validated by an authority that the browser acknowledges. So there are some mechanisms for these things, but not the actual scenario that you are describing. Let's move on because I will talk about certificate authorities as well. XSS, we already talked about that. Cross-site scripting, injection of malicious scripts into web pages. Or persistent stored script injection, scripts permanently stored in a database. Actually, I have experienced that on WordPress. There was this WordPress plugin that was like vulnerable because there are always bots that are trying to test your sites to see whether or not you have installed some vulnerabilities on your site or something like that. And typically these know of the vulnerable modules or plugins in WordPress, for example. What that bot had done, it has in some way, I'm not sure how, but it had been able to inject a script into an article in the database. And that means the script tag and some JavaScript within the script tag. This JavaScript triggered whenever the page was rendered. The page with this article was rendered. So typically you do that by sending either through a post parameter or a get parameter. You send the script tag and maybe it gets stored in the database if you know that this is a vulnerability of a plugin, for example, in WordPress. So then I got this weird functionality, and I saw that something was wrong on these pages. Actually, the client also reported it, and we had to reinstall WordPress and clean the entire database, try to go through all the articles to see whether or not there were any scripts injected and so on and so on. So it was quite a large affair. But you can also have I mentioned scripts injected with get parameters in your URL. How can you utilize this? And by that I mean, let's say www.mydomain.com and a parameter equals script for example window.alert hello world. I don't have any vulnerable pages to show you this, but this would have triggered an alert with hello world, and that means that I can more or less do actually anything if the site hadn't done the right precautions for preventing this. So that's also XSS. But why? How do we use this as an attacker? How do you use XSS? If you know that the site is vulnerable, what can we do?
We can reach a website, how it looks like, insert our forms that sends data to our servers or something like that.
Yeah, we can do that. That's what we do in the actual attack. But how can we attack?
You can, for example, make a username. If the username is not filtered correctly, you can make your username set to a script tag that redirects the user to a fake site, for example.
So I can send out a newsletter, for example, with a link in an NA tag. You see, with the link text is this new cool feature or something like that. And behind that, you have this link. The link that I wrote. mydomain.com parameter equals script window alert script. And that means that I can either start collecting the cookie of the user, for example, maybe sending it to a server where I can collect these cookies or something like that. Because the user is totally ignorant in related to this. Typically, an ordinary user wouldn't have even seen that this is a threat. We would have seen it. Maybe it does a redirect right after it has done this script job, and we won't see it either. So that means that you can do anything that JavaScript enables you to do on a page. And that means sending AJAX requests, sending information, collecting information, etc. Read the cookies that you are allowed to read on the client side. You have non-persistent or reflected script injection. That was the example that I gave you now, which are immediately passed and executed as part of an URL, e.g. injecting JavaScript through a get parameter. And SQL injection or command injection was also mentioned here. Database attack by injecting the SQL code to a DBMS. Get parameters are also vulnerable to that. Yeah, maybe you have seen this. Have you heard about Bobby tables? Some of you had. If you understand this, you have worked with databases and SQL injection. Hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way, did you really name your son Robert, drop table students? Oh yes, little Bobby Tables we call him. Well, we lost this year's students' records. I hope you're happy, and I hope you've learned to sanitize your database inputs. I suppose some of you have seen this before. Yeah, it's quite good. Yeah, so that's that says it all about SQL injection. You can also have server attacks, as I mentioned. For example, if you have programming languages that can evaluate strings and interpret them as code, because you can do that in PHP, for example. And you can do that in other programming languages as well. And if you do that on the server side, you shouldn't. If you do that with input from the client, you shouldn't do that either. But if you do it, you have to clean it up somehow, because then you can be vulnerable for scripting injection on the server side as well. Okay, how to try to be precautious and prevent these attacks? We have some security concepts. Many security concepts are related to QoS, quality of service. If you remember that, we talked about that. Authentication, that means verification of identity with passwords, tokens, electronic cards, or any other authentication method. Authorization, which allowed actions do you have? We've already talked about this, so I'll skip quite rapidly through it. We have some security concepts in QoS, if you remember these. Confidentiality, we want to keep information secret from a particular user, or so from particular users. We want data integrity, keeping data uncorrupted with techniques as hashing, checksums, etc. Let's take these two, confidentiality and data integrity. What type of attack would lower your confidentiality score if you would have measured this in some way? You want to keep information secret from particular users. Stealing cookies, for example. If that's possible on your system, that will lower your confidentiality score. What about data integrity? Keeping data uncorrupted. What kind of types of attacks?
SQL injections.
Yeah. Others?
And HTML, this XSS HTML, because you can treat your web pages data as well, and it's corrupted.
Yeah. But in particular, I thought of eavesdropping. Looking at TCP packets, maybe changing them, That changes the data integrity. And phishing. Also mentioned. Yes. Non-repudiation. Digital signatures to protect and ensure digital trust. Endorsement statements from a known participant. We use that with SSL certificates that sites use whenever you're on HTTPS. We can look at the different layers. If you remember the OC layers. Transport layer security, we typically use SSL or TLS for this. Cryptographic protocols operating above the transport layer. And if we use HTTPS, we have HTTP over an SSL connection or a TLS connection. So this protects us from eavesdroppers and man-in-the-middle attacks. We use certificates. So typically, when we set up HTTPS, we apply for certificates on some kind of certificate authority. Do you know any certificate authority?
Symantec, I think. Symantec.
Yeah. We use bypass here. They issue certificates and are endorsed by browsers. So, have you heard about Let's Encrypt?
Yeah.
Yeah. That's a free alternative for certificates. They have now been, I think they have been endorsed by some other certificate authorities that are being used by other browsers. So now we can actually use Let's Encrypt for free to set up HTTPS on web pages. Yes, we use tokens whenever we want authentication, like JSON Web Tokens or OAuth for authentication between different services. Kerberos is also another type of token. If you want to look more into security and web applications, you can look into the OWASP project. Open Web Application Security Project. It provides guidelines, methodologies, technologies, and tools for security measures in applications. So if you go to their web page, we see here that we have a lot of resources. We can, for example, look at type of attacks. And this is a larger list than I gave you now in this lecture. So these are the type of attacks that you have to prevent for, and several different types. And then also how you can prevent these kind of attacks. So OWASP, that's a great source for security in web applications. Yes. Okay, what about web services? How do we ensure security there? There are several standards that are related to what I already talked about there. You have XML signature, XML encryption, XKMS certificates. You can use SAML and VS Security and VS Trust. Let's look into them. Service-based authentication and authorization. Typically, you can use directory services like LDAP or Active Directory. authentication and authorization protocols that you have available: OAuth, Kerberos, OpenID. But what about web service security? XML signatures is a standard to use in web services. Now I'm talking about the web service standards, not REST type of services, but web services. It's an XML syntax for digital signatures and typically used over SOAP. You can look into an example here. So this is a signature that can be passed with a SOAP response, for example. We have XML encryption of XML element content. So within SOAP we can encrypt data. In this example we're encrypting the entire credit card element, and we get this cipher data here within cipher data element. So in this way we can actually have secure SOAP messaging over HTTP. You don't need HTTPS for this kind of conversation. As long as we encrypt all the messages with XML encrypt or XML encryption, we can do that. Certificates. I've already talked about certificates. Digital certificates issued by the trusted authority, e.g. by using keys for signature validation. So trusted authorities are typically those issuing these kind of certificates, and they are also endorsed by the browser. So the browser knows that bypass is okay. So if you have a bypass certificate, I can tell the user that this certificate is valid and okay. So have you seen these green bars in the address field of your web browser? I suppose we get it from, if we go to facebook.com, for example. Not there. But you get a green bar here. So it depends on what kind of certificate you're using on your HTTPS service or web page. SAML security assertion markup language is an XML-based security information language. Information about identity, authorization, and access. So we can pass this with SAML requests and responses within. Yeah. So this means that this enables portable trust across domains. So if you have this kind of service orientation where you pass information between different domains and different services in a long chain of workflow, you can keep this trust across these requests and responses within the workflow. It facilitates web browser single sign-on. Have you heard about single sign-on? You log in once, and in a related service or a related web app or a related native app, you are still logged in because you should be logged in only once. This wasn't possible before. For example, SAML, or now it's also possible with OpenID, for example. This is the workflow of SAML and SSO, single sign-on. I won't go into detail there. I don't think you see either. But you can look into it on your laptops. And we have VS Security defines how assertions and other security tokens can be attached to headers of SOAP messages. Here's an example of that. And VS Trust. Participants need to determine whether or not they can trust the security credentials exchange. So VS Trust defines additional primitives and extensions for issuing, exchanging, and validating security tokens. So the typical process is that a service specifies required claims using VS policy. A SOAP request arrives at the service, and VS Trust requires that the message prove a set of claims, for example, name, key, permissions that you have, etc. So these are used in web services, but they aren't actually very relevant to what we are doing with web development, because most of the web developing world have moved on to REST APIs instead of web services. So this is for automating trust and validation, authentication, authorization between systems that is based on web services. Yes. So I won't go more into detail on that. Okay, we'll take a break, and I'll finish up with polyfilling after the break, and then we'll have a workshop after that. Okay, so 10 minutes, 1:15. 2. Okay.